Alright, welcome back. This is AP video 10.5, looking at phase changes and energy processes. Main objectives are to classify the 6 phase changes and then be able to identify if they are an exo or endothermic process. Get yourself ready, pause, rewind as you need to. Let's go. So these are the phase changes we talked about in chemistry. You got your solid to liquid to gas, and you can even go from solid directly to gas or back and forth. Let's look at the one I want to do in our notes, which is this one. Go ahead and put down your different phase changes. So we start off, we have solid to liquid is melting, and if a liquid goes back to a solid, it's freezing. Then we got our liquid going to a gas, that's called vaporization, or in layman terms you might hear the word boiling, so you can write that down as well. And in a few videos here we'll talk about evaporation versus vaporization. What's the difference? When a gas goes back to a liquid, that's called condensation. And if you do the big jump from a solid all the way to a gas, that's called sublimation. And if a gas deposits itself back into a solid state of matter, that's called deposition. What I really want to focus mostly on this video though is the energy process, what's taking place there. So I'll do most of my focus here on the liquid state of matter and heating it up or cooling it down. So here we go. If you want a liquid to become a gas, that's called vaporization, you must heat up these particles. Energy must flow into this, and therefore when you heat it up, they move faster, and then they eventually become gas particles. Okay? And because energy must be supplied to get it to heat up and become a gas, that's got to be an endothermic process. Energy is required. Energy is going to be absorbed by the liquid. It's going to flow into the system, and that's an endothermic process. So the reason some students struggle with this is because we're saying we have to heat it up like a hot plate. When you usually think hot, you think exothermic. But don't forget, this is the surroundings. The surroundings are hot, and when they are hot, they will transfer energy to something that's colder. Remember, heat flows from hot to cold. It'll heat those particles up, and when they move faster, they become a gas. So heating things up is an endothermic process. Now vice versa. If you want this liquid to become a solid, you want to go this direction, now we're going to freeze it. Well, in that particular situation, it's the exact opposite. The surroundings are, I'm going to put a C here, surroundings are colder. Alright, and because the surroundings are colder, energy is going to be drawn out of your liquid particles, and when energy flows out of there, that's actually exothermic. So with regard to the system here, energy is flowing out, and therefore it's an exothermic process, and then the particles slow down and they start to re-solidify into a solid. So that's why it's exo. So, and again, because you hear the word exo, you're thinking hot. That's not always the case here. So again, energy is flowing out, and that makes it exothermic, and it goes from hot to cold. So your colder surroundings will draw energy out. So just kind of heads up on those. Be thinking about that a little more closely now as you do these. And just don't take for granted exothermic means hot. It's all about which way is energy flowing with regard to your system. Energy goes in, endothermic. Energy goes out, exothermic.